All right, we are going to keep this brief. This is adding and subtracting polynomials. Specifically, what is a polynomial? A polynomial is a monomial or a sum of monomials. Well, what is a monomial? A monomial is a single kind of algebraic expression. And if we have two of them, we have a binomial and a trinomial. So if I was looking at like a part of this is a monomial. But now since I'm adding two monomials, it's a binomial. Bi means two. Tri means three. There are three monomials here. We talk about the degree is the greatest exponent, basically, here. It's in standard form when the exponents go decrease left to right. So notice how it goes cubed, squared. This is a silent exponent of 1. We call that a constant because it has no variable. The first coefficient, which is a multiplier, that is the leading coefficient. So in this case, the leading coefficient is 2. The degree was 3. As I look through here, I've rewritten these problems into standard form. Notice they go from highest exponent to lowest with ending with a constant. This one was already in standard form. It was only 1. We go highest exponent, next lowest. Not to get confused with the coefficients. We're talking about exponents need to be in order. So it goes 4, 2, 1. The degree is the highest exponent. If there's no exponent and it's not a constant, it's a degree of 1. So this one's a degree 8. The leading coefficient, I abbreviated that with LC, is the first coefficient in standard form. That's key. That the in standard form is where you find the leading coefficient. If there's no coefficient, it's a coefficient of 1. You could see here I named these all trinomials, monomials, binomials, trinomial. 3 terms, 1 term, 2 terms, 3 terms. Again, these are terms. I'll post some extra resource videos for this, but here's a quick brief overview. When we find the sum, we are adding terms that are the same. We are combining things that are the same. When you're adding, the parentheses don't really make much of a difference, but it helps group them together. So negative 4x and 6x go together, and we don't combine exponents. When we're adding, we're just collecting things that are the same. 9 plus negative 14 is negative 5. Be careful if it's not in standard form. Notice I rearranged this one down here so that it was easier to track my different terms. Notice that the 3, negative 3 and the 7 didn't have anything to add to it, so we just left it like this. Even though both of these have exponents, they can't be added. This is representing t times itself 3 times, and this is t times itself twice. And they're being added, not multiplied, so we can't add their exponents. Little trick for subtracting here. When we're subtracting polynomials, it might be useful to subtract the whole quantity. We'll look at some area problems later. But you can distribute this negative inwards to that. Boom. That's kind of a key thing for finding the difference, which means subtraction, is send in that negative almost like a negative 1. All right, lastly, this is something to build number sense, okay? So mental math, build number sense. The idea is that if we take a number like these, we can add them in our head by breaking them up into their digits. So I called 340, 340, 720, and 4. These are just easier numbers to add. I can go 300 plus 700, 40 plus 20, and then 4, boom. Much easier and quicker if I'm trying to build that number sense. We could also change this to something that's closer, like on the upper end. Like 5,000 minus 12 would be a much more concise way to write 4988. And I can do the same thing. I've broken it up into its pieces. And now when I add them together, it's easier to track my like terms. It's a strategy. It's building number sense. It is not imperative that we use that.